In this chapter, we will teach you about the scientific revolution. In 1500s to the 1700s, modern science emerged. There were only two ways that the Europeans relied on their understanding of nature: the Bible and religious teachings.
The scientists would ask new questions and would answer them in many different ways. Inventions like the telescope showed the universe no one had ever imagined. With observation, they showed errors in some experiments.
Aristotle was an important figure. He had a theory about falling objects. He thought heavier objects would fall faster than lighter objects. This theory was proven wrong by another important inventor named Galileo Galilei. He dropped two balls of different weights from a high point, and he surprised many educators and scholars with the results.
The scientific method uses logic and observation.
In the rest of this lesson, you will learn about the roots of the scientific revolution. You will also meet some key people during this time, and you will learn about their discoveries and inventions.
The scientific revolution changed how people understood the world.
First, we will talk to McKenna about the roots of the scientific revolution.
In this section, you will get a close-up of the scientific revolution. First off, what is the scientific revolution?
It was a major shift in thinking between 1500 through 1700. During this time, modern science became a new way of gaining knowledge about the natural world. There were two other ways of gaining knowledge: the Bible and the teachings of Aristotle.
Aristotle had written about logic in the 300s BCE. Many thinkers began to question the conclusions of earlier thinkers during the Renaissance. Renaissance scholars rediscovered the cultures of Rome and Greece using ancient scriptures and artifacts. They made advances in fields such as medicine, math, and astronomy, and learned about a variety of details. Greek rationalism was one way European philosophers were influenced.
Rationalism was a belief in reason and logic that was used to discover basic truths about the world.
The thinkers also liked to observe nature directly, like one physician named Vesalius. The age of exploration also helped with the growth of science, and the scientists' work led to many dramatic and new discoveries.
Sit down and get some paper out. We're taking notes today. Today, I'm going to show you a whole new view of the universe came to be. Nicholas Copernicus and Johannes Kepler were the people who made it possible. Are you awake? Nearly 2,000 years ago, people believed in the geocentric theory, which was that everything in the universe revolved around the Earth. This theory was taught by Aristotle. In the early 1500s, however, Copernicus proposed a very different idea.
What was the idea?
Melody, calm down. The idea was the heliocentric theory, a theory that placed the sun at the center of the solar system. Copernicus was not the only one who believed in this heliocentric theory. Who expanded his ideas and theories?
Johannes Kepler.
Correct. Kepler was one of these key people who involved in proving the Copernicus theory.
Didn't Kepler also figure out that the orbits of the planets were ovals, not circles?
Yes, groovy. That's a 60s word. All of the evidence Kepler provided proves Copernicus' theory. To end this lesson, Kepler's laws agreed beautifully with actual observations. This was evidence that Copernicus' theory was correct. Now get out of my classroom.
I see.
After Galileo's invention of the telescope based off of an invention he had heard from the Netherlands, he used its intense magnification power to observe the outer solar system.
What's this? The surface of our moon doesn't appear to be smooth. It seems to be more or less rough. It also seems that Jupiter has the same type of moon we have,
only many more.
Galileo studied moons very avidly, discovering aspects such as its texture to the amount of moons in our solar system, not to mention much more.
Ha! It looks as if our planet Venus, that we have seen for so long as a bright star, goes through many phases just as our moon does. These discoveries will surely shock the world. However, how am I to present my groundbreaking news without angering the church? It is a topic I will need to think much about.
At this time in history, it was forbidden to question the church. History did this, and in addition, it contradicted the original view of the universe. The idea of the earth was not the center of the universe, and the earth orbits the sun was known as the Copernican Theory.
We will not let you teach the Copernican Theory. It goes against a part of our religious system. The public shall not be allowed to hear this outrageous new theory.
Galileo returned home. Frustrated by the church, he refused to be silenced.
I can't publicly speak of this, but I shall make myself known in some way.
Because Galileo was not allowed to publicly share his theory, he expressed it in a book. This book basically described a typical conversation between a believer of Galileo's theory and a non-believer. Galileo never took a specific side, but he did give a clever argument in which he hinted that the person who believed in his theory was more intelligent than that person who didn't.
I shall title my book Dialogue on Two Chief World Systems. If the church has a problem with it, I will be forced to back it up with reason.
Galileo was called to face the Catholic Church, called an Inquisition.
Galileo, you must go to Rome to face the Inquisition.
The trial did not go very well.
You were going against all religious teachings. You must confess that you are wrong.
No, I won't do it.
Galileo was forced to admit that the geocentric theory, which says that the Earth is the center of the universe, is true.
You must take it back. Swear that the geocentric theory is the right theory.
Okay, fine.
You will also not be able to write about the Copernican theory ever again.
All right, the geocentric theory is true, and I won't use the Copernican theory again.
The ideas Galileo still spread, even though the church opposed. Many scientists read his dialogue, and this helped him get more believers. His studies of motion helped the scientific revolution move forward. His theory of motion also describes how objects move on Earth. In the end, the church didn't stop him from coming up with some great ideas.
I was told today I'm supposed to teach you about Isaac Newton and the law of gravity. Isaac's mission was to figure out what kept the moon traveling in its orbit around Earth.
A while before,
One day he saw an apple fall from a tree and it hit the ground.
It seems to be that objects fall towards the center of the Earth.
from this realization, he concluded that even heavenly bodies fall towards the earth, the center of the earth.
This is called gravity. But because the moon is farther away, the force of gravity only pulled the moon into orbit and changed its path so that it revolved around the world.
His formula for the law of gravity proved that physical objects have attraction between them.
The strength of the force of the object depends on the mass and the distance of the object. The book Principia describes the three laws of motion. Newton's laws provided an explanation for what earlier scientists observed, the planets and the universe in general.
The end result was that his laws changed the way of people throughout many things, such as the universe.
Hello, we are going to tell you about some key inventions that were made during the scientific revolution.
We're going to talk about microscopes, barometers, and thermometers. First, we're going to give an explanation of microscopes.
All types of scientists use microscopes. The first microscope was made by a Dutch lens maker named Antony van Leeuwenhoek in the late 1500s. He designed his own microscope. Leeuwenhoek was also the first person to see bacteria. He was really surprised to find out that there was a tiny world of living things.
Next, we're going to talk about barometers. Barometers are tools that measure changes in the pressure of the atmosphere. In the 1640s, the first barometer was invented by Evangelista Torricelli. What he did was place a tube filled with mercury upside down in a dish. Torricelli realized that the height of the mercury changed over the course of a few days. He came to the conclusion that the movement of the mercury was related to the pressure of the atmosphere. The barometer then became a way to study and predict weather.
Finally, another thing that scientists discovered were thermometers. People suspect that Galileo made the first thermometer. However, in the early 1700s, a German scientist named Daniel Gabriel Fahrenheit made the thermometer more accurate. He put mercury in a glass tube, and when it got hot, the mercury rose. Only in the United States do we use Fahrenheit degrees.
Although many things were made by scientists, these are a few key inventions that were invented during the scientific revolution. These three tools and many more help scientists discover new things that has influenced the modern world exponentially.
Today we're going to learn about the scientific method. The scientific method was a key idea during the scientific revolution.
The two philosophers who influenced this development were Francis Bacon and René Descartes.
Francis Bacon was born in England in 1561. He disagreed with the traditional learning of the Middle Ages and believed that people have to get rid of false beliefs to gain knowledge. He constructed a method of scientific investigation that focused on close observation.
René Descartes was born in France in 1596, and he prized logic and math. He believed that people should question everything until proved to be true. He saw the physical universe as obeying universal mathematical laws.
These ideas by these very clever philosophers led to the scientific method.
Scientific method combines logic, math, and observation and has 5 steps.
The 5 steps that scientific method uses are 1. The scientist states a question. 2. Forms a hypothesis. 3. The scientist conducts an experiment to test the hypothesis. 4. Measures the data and records outcome. 5. Analyzes the data to see if correct. Galileo used these exact steps when conducting the experiment with the falling objects.
We still use this today, and scientists can compare their ideas and can conduct the same experiments.
The scientific method changed how people think. They no longer depended on traditional authorities for answers to scientific problems. Science was a better way to understand the world. In this chapter, we learned about the scientific revolution. This important movement marked a major shift in the way people thought about the natural world.
Woo, 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 woo! Round of applause for all the actors. Yay! Okay.